Video, we're going to learn to graph standard form of a quadratic, vertex form, and also intercept form. So the first one's in standard form, and we can tell this is in standard form because it's written as ax squared plus bx plus c, where we have an x squared, an x, and a constant term, no parentheses or anything. It's the most basic form of a quadratic or a trinomial. So step one is that we always find the axis of symmetry, because when you find the axis of symmetry, it leads you to be able to go find vertex. And once we find the vertex, we can make a function table where the vertex should always go in the middle. All right, so first to find the axis of symmetry, we're going to do the formula x equals negative b over 2a, where 2 is a, negative 8 is b, and 6 is c. So x equals negative b would be 8 because b is negative, so negative b makes it a positive 8 over 2 times a, which is 2. This is x equals 8 over 4, which leaves us with x equals 2. You must write it as x equals 2 if a test or a quiz is saying identify the axis of symmetry. It needs to be written as x equals 2 or it's incorrect. If you just write 2, it's not right. So that's our axis of symmetry, and that leads us to go be able to find the entire vertex. But we should also graph the axis of symmetry as a dotted line at x equals 2. Like I said before, we're going to use that to find the vertex. So you'll plug in x for the function. F of 2 equals 2 times 2 squared minus 8 times 2 plus 6. And we use PEMDAS here to simplify. So that's going to be 2 squared. We do exponents first. 2 squared is 4 times 2 is 8. Negative 8 times 2 is negative 16 plus 6. So basically each term gets simplified first and then add or subtract all of them together. But make sure that you do this exponent first. It's really, really important, especially if all that's over here is a negative. It's important that the exponent comes first. And then we get negative 8 plus 6, which gives us negative 2. So the vertex is 2, negative 2. You can plot that on our graph. And if you know how to stretch or compress the parent function, you can just find the points automatically. But the way that we do it in class is that we pick 3 points before the vertex. So this would be 1, 0, and negative 1, and 3 points after the vertex. Okay. You can pick 2 points before and 2 points after, but you need to pick enough points that you can find the solution on the x-axis. So let's start with 1, and we know that 1 is going to reflect 3. So whatever I get for 1, I'll also get for 3. So if we plug in 1, I'm going to do my work down here. F of 1 is going to be 2 times 1 squared minus 8 times 1 plus 6, which is 1 squared is 1 times 2 is 2 minus 8 plus 6. 2 minus 8 is negative 6 plus 6, which gives me 0. So if you plot these, you're going to notice if we get 1, 0 and 3, 0, that those are your intercepts. You should definitely always choose at least 5 points. So even though we already have my intercepts, I'm just going to plug in 0, and 0 looks pretty easy. Both terms cancel out and we get 6. So it's a good idea to at least do 5 and do as many as you need until you get an intercept. So 0, 6, and 4, 6. So that you can see that this is a pretty skinny parabola. If I plugged in negative 1 or 5, it would definitely be off the graph, so it's not necessary. Okay, draw nice lines, curved, coming to a point. Notice that the legs of the parabola are getting wider as it goes up, and that shows that the domain is going to be all real numbers. So the domain of a parabola is always all real numbers. And the range is the lowest point, negative 2, to the highest point, which is infinity. Notice that negative 2, any number always has a bracket on it, while infinity signs always have parentheses around them. Okay? If you needed to identify the y-intercept, it would be 6. And the x-intercepts are the solutions or the roots or zeros or whatever we want to call them. It's what we draw in squigglies. So x equals squiggly 1 and 3. So if I was asked to solve by graphing, that would be the way to solve by graphing, is to give the solutions 1 and 3. The form that we're going to graph is vertex form. Vertex form is written as y equals a x minus h squared plus k, where a is a stretch or a compression, just like it is in standard form, and h and k is the vertex, where the inside number lies and tells you the opposite sign of what the vertex actually is. So I can tell that this graph can be set by a factor of 4. And that's important because it tells you that you're going to have a really skinny parabola. And if you don't, then you know that you did something wrong. So I saw a lot of people in the quiz had their parabolas facing the wrong way, up or down, but most of their points were really close to being correct. That means that you didn't check if A was negative or positive. So make sure that you use the knowledge that we have to check and see if your work is right. So automatically I can see that the vertex is 1, 1, because the inside number always lies to you and the outside one doesn't. So that's going to be 1, 1. This is a lot easier than standard form because I don't have to find the axis of symmetry. I don't have to find the vertex. It tells all of that. I still put it in the middle, and I'll pick 2 points before and 2 points after. And if we need more, we can always plug in more. So let's start with plugging in 3. 4 times 3 minus 1 squared plus 1. PEMDAS is really important here. You use PEMDAS in every step. So 3 minus 1 is 2. Squared is 4. Times 4 is 16. Plus 1 is 17. So you can tell that this point is nowhere near on my graph. I don't necessarily need it, which would mean that negative 1 is too big as well. Okay, and that's okay because this graph was stretched by 4, which is a lot, meaning it's going to be really tall. If you wanted to plot your vertex, that is 1 point we do know already. All right, let's plug in 0. 4 times 0 minus 1 squared plus 1. 0 minus 1 is negative 1. Squared is 1. Times 4 is 4. Plus 1 gives us 5. So that's actually a good point. And we get 0, 5, and 2, 5. So you can see that the next point after the vertex is already really far away. And we have a very skinny parabola because the size of the normal parabola was multiplied by 4. Okay. The domain, like it always is all real numbers. The range is the lowest point to the highest point. The y-intercept would be 5 right here. And as far as solutions or x-intercepts or roots or zeros, there's no solution because this graph never crosses the x-axis. Right here. The next type of parabola that we're going to graph is intercept form. Intercept form is also pretty easy because the goal of graphing is to find the solutions. This gives you the solution. So you would set these guys equal to 0 and solve for x. And we already know that x is going to be 5 and 1. So I'm going to plot those. Those are my x-intercepts. And we know that this is an intercept form because it's in factored form, parentheses that are binomials. So when I make my function table, these points don't necessarily need to go in the middle, but I need to include them. So I definitely want to do 1 to 5 and maybe points after that, but it's not really necessary. The axis of symmetry is going to be directly in between these points, which means it's at 3. Between 1 and 5 is 3. So I know that this is the axis of symmetry, and this whole thing will be the vertex. So we can plug in 3 to find out what the vertex is. So we know we have 1, 0, 5, 0, and the vertex. We could plug in 2 and 4, but it won't be necessary once we have the vertex. So y equals 2, 3 minus 5, 3 minus 1, y equals 2 times negative 2 times 2. 2 times negative 2 is negative 4 times 2 is negative 8. So we have a vertex of 3, negative 8. And that looks like enough to draw a parabola. You could plug in 2 and 4, but I have points that are pretty far apart, and I also have the intercepts and the vertex. That's really all you need. So on a test or a quiz, I would definitely go with 5 points, or at least enough points to cross the x-axis. And I might even want my y-intercept here. If I plugged in 0 for x, that might be a good idea, just in case the test asks you for the y-intercept. So 2 times 0 minus 5 is negative 5. 0 minus 1 is negative 1. That gives 10. So you would almost not even see that. It would be right there. Okay, so that is graphing in intercept form.